So, good morning. So, in the last class, we were discussing about the process of runoff, and also we have discussed something about what is a watershed or a catchment area, and what are the different types of catchment area. So now, in today's class, we shall discuss the factors of the runoff. So the factors which are mainly responsible for runoff, or which influence or which affects the overland flow runoff, are the precipitation characteristics, and the shape and size of the catchment, and also the topography of that area with respect to mean sea level, and also the geological characteristics of that particular area, and also the hydrometeorological characteristics. So hydrometeorological characteristics are nothing but it is the precipitation characteristics and the meteorological characteristics, and also the character of the catchment surface and the storage characteristics. So these are the factors which influence or affect the runoff process. That is the precipitation characters, shape and size of the catchment, topography, geological, meteorological characteristics of the catchment surface, and storage characteristics. Now, the precipitation characteristics are nothing but it is the most important factor for runoff, because whatever the water that comes out of the catchment area is the remaining part of the rainfall. So hence, it is the most important factor for runoff. Runoff depends on the type of storm and its duration, which causes precipitation. So that means it also depends on the intensity of rainfall and also the areal extent, how much area it covers in that particular catchment area, and also the duration of the storm. More the rainfall, obviously, if there will be greater runoff. If the rainfall intensity is very less, and it rains as the light shows, then much of the water will be lost in infiltration and evaporation, resulting in less runoff. So mainly, the intensity of rainfall should be always greater than whatever the infiltration and other losses. Then only we can expect some volume of runoff from the catchment area. If precipitation is in case of snow, then there will be a less runoff. So especially in Himalayan ranges, especially in the month of summer, even the rivers are perennial, they receive. So please don't mark your attendance in the chat box now. I will tell when to mark. Now, if precipitation is in case of snow, there will be less runoff. Now, the second factor which affects the runoff is the shape and size of the catchment. So runoff mainly depends upon the size, shape, and location of the catchment. Generally, more rainfall on smaller area resulting in greater runoff. If the area is very small and if the intensity of the rainfall is high, then you will have a better runoff volume. So less runoff in large catchment because due to the non-uniform rainfall over the entire basin, because the rainfall will not be uniform over the entire basin. It differs from a place to a place. So hence, less runoff in large catchment because due to uniform rainfall over the entire area. Thus, only few tributaries of the stream-fed water to a mainstream during a particular storm. So we have discussed what is a catchment, and in a catchment how the natural river runs, and to these natural rivers you have many sub tributaries, and also we have discussed about the influent stream and effluent stream, and also the numbering of the tributaries in a catchment area, and type of catchment. So it also depends on hello class is Karthik. One section A. B section. So types of catchment. So there was a call. Okay, fine. So types of catchment. One is the fan-shaped catchment. The other one is the fern leaf catchment. Now you can see here the types of catchment. There are figures. So now here you have a fan-shaped catchment. So here, when compared to the length, it has a greater width. Hence, the tributaries will also take the same time to the water to join the mainstream. So all the tributaries are approximately of the same size here. So gives greater runoff because the peak flood from the tributaries is likely to reach the mainstream approximately at the same time. So here, in case of fan-shaped catchment, you will have a greater volume of runoff, and the time taken by the water to reach this concentration point is also less, that is the time of concentration. Hence, fan-shaped catchment produces a greater volume of runoff. Now here you have a fern-shaped catchment. It almost looks like a plantain leaf. Here you have the tributaries, so of different sizes. And here the time taken by the rainwater to reach the concentration point is very high. So hence the volume of runoff expected at this point is obviously less. The tributaries are generally of different lengths and meet the mainstream at the regular interval. Such a narrow catchment, the peak flood intensity is reduced since discharges are likely to be distributed over a long period of time. Hence, the time of concentration is more. So in the first case, the time of concentration is less. Hence, you have a greater volume of runoff measured at the concentration point. Now you can see the graphs. Here you have two graphs, one with respect to a fan-shaped catchment area, the other one with respect to a found-shaped catchment area. So now you can see here the hydrograph. Hydrograph is nothing but a graph of discharge versus time. So here it attains a peak at a very early stage. So in case of a fan-shaped catchment area, the attainment of the peak takes some more time. That means the time of concentration is greater in case of fan-shaped catchment compared to the fan-shaped catchment. So these are the two figures which clearly explains the process of runoff in case of fan-shaped and also the fan-shaped catchment. Now, large catchment means less runoff. Less number of streams means also less runoff. Lesser stream flow because the flow is gravity. So if you have a lesser stream flow, then obviously you will have a lesser runoff. Fan-shaped catchment produces high peak at outlet. Now, next, the factor which affects the runoff is topography. The runoff depends on the surface smoothness and also the slope towards the concentration point. If the slope is steep, flow will be very quick and less absorption and evaporation, resulting in greater runoff. If the catchment is in a mountainous area and on the windward side of the mountain, then more rainfall resulting on the windward side. So hence you have more runoff on the windward side. So this is nothing but we have discussed in the first module, and that is the orographic precipitation. Now the geological characters also play a very important role in case of the runoff. It is one of the important factors. It includes the type of surface soil, subsurface soil, type of the rock and their permeability characteristics, because water flows through the ground surface through the hydraulic conductivity. If soil and subsoil is porous, seepage will be more, resulting in reduction of peak runoff. If the soil surface is rocky, then the absorption will be nil, resulting in more runoff. If rocks have fissures or porous in nature, have lava funnels, water will be lost, resulting in less runoff. So these are some of the geological characteristics which affects the runoff. Next is the meteorological characteristics. So runoff may also be affected by the temperature, because temperature plays a very important role in case of evaporation losses, and also the wind and humidity in the atmosphere. And if temperature is low, the ground is saturated, then the runoff will be greater. If the temperature is high, greater wind velocity gives rise to greater evaporation losses and resulting in less runoff. On the other hand, greater humidity decreases evaporation and transpiration losses, resulting in the greater runoff. So now, the character of the catchment surface, runoff also depends on the surface condition like drained, undrained, natural or cultivated. So if the surface has no natural drainage, then the absorption losses will be high, and hence the runoff volume will be less. If the more area of catchment is cultivated, resulting in less runoff. If in the particular catchment area, if more agricultural activity is happening, then obviously whatever the water is utilized for the agriculture purpose, hence the resulting runoff will be less. Suppose you have seen in some places on the mountain areas where you have mountains, there is unauthorized cultivation without any permission. This might be one of the reasons for having a less runoff at the concentration point. Next, vegetal cover reduces the runoff in smaller storms, especially in forest areas. If we have a light shower, then everything will be intercepted by the forest vegetation. Hence, you will have a lesser runoff. So this is a very complex problem to analyze the various types of things that happens in a catchment area. So next, storage characteristics. Next is storage characteristics. The artificial storage such as dams or weirs and natural storage such as lakes, ponds, etc. tend to reduce the peak flow, but you cannot avoid this because some water has to be stored in this structure, especially in the southern parts of India. We have to store some portion of the water. We cannot allow the entire water to join the ocean. So some portion of the surface runoff is arrested by means of these dams, walls, lakes and ponds. Examples, depression pools and ponds, streams and check dams also you can have. They also give rise to greater evaporation losses. Obviously, in every system there is equal advantage and also some disadvantage of us. Next, the need of runoff. So why this runoff component is very important means the design of drains, canals and other channels areas, and prediction of water level in streams and rivers, storage for irrigation, power generation and a river transport. So it is a multi-purpose reservoir project. Now, so far we have discussed what is the process of runoff, how does it happen, and what are the different factors that affects the runoff. And now we can estimate the volume of runoff measured at the concentration point by using the following things. That is, one is the empirical formulas and curves and tables are available to estimate the runoff, and also by infiltration method. Infiltration method, you can estimate how much water it has infiltrated and the remaining water that comes out as treated as runoff. So this you can simulate in the laboratory also. This model you can simulate in the laboratory with the outside site. You can simulate and you can find out the quantity of water that comes out of the catchment area. And also you have some rational methods also. And you have overland flow hydrograph analysis with respect to fan-shaped and fern-shaped catchment area. And this is one of the very sophisticated method, that is the unit hydrograph method. So we shall discuss in the later sessions. By this method you will get a very precise value when compared to all other methods. So these are some of the empirical formulas or methods to estimate the runoff. Now this is one empirical formula. So here it has been given for plain area and mountain area. So this formula is given by a gentleman, English formula. So it is of the form R into P minus 17.8 P times divided by 254. And for hilly region, so in order to estimate the runoff, you have to use this formula, where P is average yield from the catchment. That is 75 to 80% of the average annual rainfall. So in a given area, you can have the average annual rainfall for number of years, for 35 or 40 years. And from this average annual rainfall, so the average yield will be about 75 to 80% of the annual average rainfall. So now next is the rational method. So it is of the form Q is nothing but the discharge in Qmax, so is equal to cap. So where C is nothing but the runoff coefficient. So this runoff coefficient mainly depends on the type of the surfaces, whether the surfaces of the area is rough or porous in nature. So the runoff coefficient mainly depends on the surface condition of that particular area. And A is nothing but the area of the catchment in kilometers square or in hectares. And also P is nothing but the precipitation that takes place. So you have the precipitation value. So this value of P, you can assume it between 75 to 80% of the average annual rainfall. So this is the available or dependable precipitation in order to calculate the runoff from a particular catchment area. Now these are the values of runoff coefficient. So it depends on the type of the catchment. If the catchment is having a rocky and impermeable area, the value varies between 0.8 to 1. And if it is slightly permeable, then it may vary from 0.6 to 0.8. And if it is a cultivated irrigated area, then it can be about 0.5. So if it is a sandy soil where you have a high infiltration rate, then the runoff value, coefficient value is between 0.2 to 0.4. And for forest vegetation, if you have forest vegetation where you have less runoff, so hence the value of runoff coefficient is also in between 0.1 to 0.2. Now, you can establish a relationship between the rainfall, that is the precipitation, and the resulting runoff. So these are some of the methods by which you can have or establish a relationship between rainfall and runoff. The usual empirical formula that is normally used is the linear regression method, so that you can establish a relationship between rainfall and runoff. And these are some of the other methods or formulas by which also you can establish a rainfall runoff relationship. In your syllabus, you have only this one, that is the regression analysis. Now, rainfall runoff relationship by using the linear regression analysis. I think you know about the correlation and regression. I think you have studied in your statistics class. So you can establish any relation, linear regression. Linear means it's a straight line regression analysis between any two variables. So in our case, the variables are runoff and the rainfall. Now, definition. The regression analysis is a technique of studying the dependence of one variable called the dependent variable on one or more variables called the explanatory variable. So in our case, the rainfall becomes a dependent variable and the runoff becomes a explanatory variable. So with a view to estimate or predict the average value of dependent variable in terms of the known or fixed values of the independent variable. So this independent variable, so this becomes an independent variable and this becomes a dependent variable. So you can establish a relationship between the rainfall and runoff. So the regression technique is primarily used to estimate the relationship that exists on the average between the dependent variable and the explanatory or independent variable. So next, determine the effect of each of the explanatory variable on the dependent variable. So what is the effect of this independent variable on the dependent variable, and controlling the effect of all other explanatory variables. So you can have a control over the runoff process, but you don't have control over the rainfall, but you can have the control over the runoff. So that means you can improve some of the things in the catchment area. That means mainly runoff takes place from the catchment area and it is measured at the concentration point. In the process, lot of problems you may come across with the yield of the catchment. In such cases, you can rectify some of the mistakes of this dependent variable, hence you will get a better value. So now determine the effect of each explanatory variable on the dependent variable, controlling the effect of all other explanatory variable. Next, predict the value of dependent variable for a given value of the explanatory variable. So now by this method we can establish a relationship between the rainfall and runoff. Now, rainfall runoff correlation, the most commonly method is to correlate the seasonal or annual measured runoff value R with corresponding rainfall values P. A commonly adopted method is to fit a linear regression line between R and P and to accept the result if the correlation coefficient is nearing unity. So it should be nearing unity. In any case, you may not get the one unity value, but if it is around about 0.75 or 0.8, so you have 70 to 80% of accuracy. So the general equation, the equation of the straight line linear regression between runoff and rainfall can be written as R is equal to A, P plus B, where this A and B are the constants. Now, you have these two equations by which you can calculate these constant values, that is A and B. The values of the coefficient are constant. A and B are given by, that is A is n into sigma PR minus sigma P sigma R divided by n into sigma P square minus sigma P whole square. So here you have to be very careful. So you can see here this is sigma P square and this is sigma P whole square. And similarly, you can also find the value of B by using this equation, sigma R minus sigma P divided by n, in which n number of observation sets of this R and P. How many observation sets you have? You may have 10 observation sets or 20 observation sets with respect to the rainfall and the runoff. The coefficient of correlation, that is, you have to calculate this coefficient of correlation, that is R, by using this equation. So that is n into sigma PR minus sigma P into sigma R divided by square root of n sigma P square sigma P whole square into n sigma R square minus sigma R whole square. So the value of R lies between 0 and 1. So the range is between 0 and 1, and R can have only positive values. It cannot have minus 1 or minus 0.1 or minus 0.2. So the value of 0.6. So that means if you get a value in between 0.6 and 1.0, it indicates a good correlation. If it is less than 0.5 or 0.6, then I think you have to collect more number of rainfall and the runoff data. So that depends on the number of observation sets you have. So finally, you can use this expression and you can find out the value of R. So thereby, you have established a relationship between the rainfall and runoff. Now, this is the plot of rainfall in centimeter, runoff in millimeters and rainfall in centimeters. You'll get a straight line plot. So here all the points are very near to the straight line. So it's the best fit line. So here the value of R from the graph, if you plot it from the graph, the value of R also to be about 0.97. It's almost nearing to unity. So you can do it by analytical method also, and you can also do it by graphical method. So these are some of the graphs showing types of regression model. So here you have a positive linear relationship, and here you have a negative linear relationship, and here you have a relationship which is not linear, and here you don't have any relationship because it is a straight line. So hence these are some of the types of regression models. The next is the hydrograph analysis. So this hydrograph analysis is one of the very good method by which you can precisely estimate the runoff accuracy to about 80 to 90% when compared to other methods. So this hydrograph analysis. So since time is running out, so I request all of you to mark your attendance only once, please. Don't put it twice or thrice. So I think your sessionals is on Saturday and Sunday, I think, correct? Hello? Manoj? Mr. Manoj? Nitya P? Nitya?
Yes, sir.
So test ಯಾವಾಗಿಂದ ನಿಮ್ದು ಯಾವಾಗಿದೆ ಹೈಡ್ರಾಲಜಿ ಇರಿಗೇಷನ್
ಸರ್ ಇನ್ನು ಟೈಮ್ ಟೇಬಲ್ ಕೊಟ್ಟಿಲ್ಲ 29th ಅಂತ ಹೇಳಿದ್ದಾರೆ ಅಷ್ಟೇ
29th and 30th ಅಂತ ಹೇಳಿದಾರ ಓಕೆ ಸೊ ಎನಿವೇ so after today's class, if the test is on Saturday, so after the test we shall meet. Anyway, I will send the study material, module 2 study material in your WhatsApp group. So the portions for the first test is module 1 and module 2. Module 3 is not included. Okay. So anyway, so I'll end this session. So thank you so much. Have a nice day. Stay safe, stay fit.